actually did this.
I'm the one who is grading those meetings, so I know that you prayed.
Oh, good.
Okay, so you're not gonna mark us down for coding it late?
So
We're live now.
Doesn't matter.
Yeah, if you actually get really close to the camera, Hunter, it clears up a lot. Okay, maybe not.
Like, not back.
It was horrifying.
Okie dokie. So we need to start by sharing insights we had during that those thingamajiggies where we did the scrolling thingies.
Hang on.
Very technical terms here.
Because we're engineers.
It's 'cause we're engineers. At both the polynomial factor application and the rational factor function application, we're supposed to share our insights on it.
While exploring the application. Oh. Okay, so when explaining this, what do you mean application? Just doing...
No, there's a thing in the preparation. Here, I'm going to...
Oh, yeah.
Yeah.
Whee! I see.
I think it's... Nope, that's the wrong screen.
I have it up right here.
Choose the right screen. This stuff.
Yeah.
Thingy where you do this thing.
I'm looking at it, big boy. Interactive apps.
Did you guys notice anything?
No.
Any insights? Yes, no, maybe so?
Kinda. I don't know. What I've noticed is like, one, this class is obviously every week we learn something and the next week we build upon it, like by using what we learned the week prior. But just looking at this app, using a little slider thing, which is pretty neat. I'm having a lot of fun with that right now. Oh, shoot.
So one of the things I noticed is that if you're on the polynomial factors one, if you move 3 of them to x minus 1, it has a dimple in the middle. And so if there's 3 that are x minus a and 3 that are x plus a, it has that dimple.
Yeah, I'm looking at. So you're saying when you go to the, here, I'm pulling it up right now. When it's minus a.
On this one.
And
so if you have 3 plus a's and then 2 minus a's, it has a dimple here. And the greater the a value, the bigger the dimple.
Oh, I see
so
that.
If I do 3 1s, it's going to have a dimple, but it's not very prominent.
Yeah.
See it?
Interesting.
And then you can do some fun stuff like make that graph.
Yeah. I'm trying to figure out how to... get out of my way. You have that little table off to the side.
Uh-huh.
How did you... I'm trying to make that work.
The table? What do you mean you're trying to make the table work?
Yeah.
Talking about... It's like the next link underneath the other one.
Yeah.
Where it has x values and y values.
You have to do it manually with the little buttons. I was trying to just figure out if I could just input actual x values.
No, you can't. You have to do it manually.
Dang it. All right, never mind. But I see what you're saying about the dimples.
Yeah, and so it doesn't even have to be with 6. If it's the fourth order, 4th degree, whatever it's called. If it's got an x to the 4th in it, it's this one. There's still a dimple, but it's the opposite direction.
Yeah.
Versus if it's x to the 6th.
Well, it's
Which means you can
interesting.
probably get that dimple. Nope. You can't do the dimple with 2.
It's interesting that when you have it, like here, I'm going to try to pull this up as an example. How do I screen share this beautiful thing?
If you go to the left-hand side, the toolbar
Oh, I
pops
see
out.
it.
It's the green button.
Yeah, I see you. I see you. So like right here, when you have certain the factors and whatnot of it all, how there's a big pattern between the X and Y values. Like as I was first looking through the chart, it doesn't look like there's a pattern, but right here in the 1 and 2 where it's the 36s, it's basically, that's like the middle of it, and then it starts going down the X-axis negatively and then positive.
Are you sharing your screen?
I think I am, right?
Now
Right
you
here?
are.
Okay. So do you see what I'm saying? So like the 1 and 2 right here, that's the, I guess, center, if you want to call it. I don't know.
Yeah.
To explain it, but
The origin.
the origin. There you go.
Is that an
Sorry,
accurate
I'm so
term?
freaking tired right now. But then you start making it so then there's not a pattern. I had something. I'm trying to stop. I'm trying to pull it up. Yeah, nope. Up. Okay. Up. This goes down. This goes back. No, stop that.
There it is.
Aha. Yeah. But so you see what you get it.
Yeah.
Now I'm trying to figure out though, when you factor it, like how it says right there. I want to learn more about how I can just figure out if it's going to be a pattern, not having to use the graph, but just rather the actual factors and functions. There we go.
Yeah, I think that's somewhat of what we're learning today, even though today was really, really hard. The graphs. I don't know if you guys got that far.
On the prep?
Yeah.
Yeah, that was interesting.
It was interesting. Did you notice anything while messing around with the polynomial factor app and rational function app, Joseph?
If it was me, possibly won't notice a single thing. Besides just messing around with it.
Okay. All right. Then are we ready to go on to step numero dos?
Yes.
As a team, go through the 2 graphing questions from the preparation. For each part, make sure to teach one another how to find the respective aspect of the function and how it helps in graphing the function. Ensure that each team member can find the following information. So let's go to preparation. And I got that guy on this page.
Show it to me, baby.
Oh, you want to see it?
No, not
I'm
yet.
not a very good artist.
I was about to say. I think I can find a.
Because this line kind of starts to get very parallel to this line, and it kind of shouldn't be. But you get the picture.
But yeah, I get that. It's just
Yeah.
showing. Okay. I'm trying to find.
Those are my drawing skills. They're awesome.
I think they're pretty good.
Okie dokie. So let's do the first thing on that first problem. Do we all know how to find the x-intercepts?
Hang on, we're on the prep still?
Yeah, we're still on the prep.
Wait.
Just try to substitute the next value in with.
What was that, Joseph?
Oh, I was just thinking, like, you just have to like substitute the x value with a number, right?
For the x-intercepts, you have to find out when x is equal to 0.
Okay.
With x-intercepts, you need to y equal to 0.
y equal to 0. That's what I meant.
And to find y-intercepts, you need x equal to 0. So they're like kind of switching.
Okay.
So x-intercept y to 0, y-intercept x to 0.
Yeah, so you just set the function equal to 0, and then you solve for x.
Yeah.
Okay.
Do you know how to do that, Joseph?
Is that required now that one breakdown from the last time where you just had to do that division process?
The what process? The division process? You don't have to do the division process if you're a math wizard or something. I'm sure you could just have this stuff memorized.
We're not all like you, man.
I didn't have it memorized. Here's where I did my synthetic division, right there in that corner.
Oh, I see.
That's
Yeah.
the one I was talking about. That's the
So
one
then once you factor it, what do you do, Joseph?
once you factor it,
Yeah.
once it's all factored out, you set don't you set in each of those parentheses like equal to 0 and then just solve for the x one?
Correct. So do you have x-intercepts for this one, Joseph, or do you got to work through that?
I gotta work through that one.
Okay.
Now,
Do you have your answers for that, Hunter?
I do, but I don't know if I put them right. Like, for example, like y-intercept would be 0 and then 24. And then x-intercept is 4, 0.
0 and 24?
Hang on. Oh, and the multiplicity of the x-intercepts. Okay. So when it's
Yes.
written as a
But
point,
for the y-intercepts, you have 0, 24.
yeah.
Shouldn't it be negative?
Or sorry, negative 24. Yeah, you're right.
Okay.
And then the x's is 4, 0, 3, 0, 2, 0.
That's what I got.
Okay. Now this is what. So the.
Do you know the multiplicity of those, Hunter?
No. What is it asking when I?
So, for instance, if it had more than one multiplicity, you could have a repeat in the equation, right?
So it's the
So,
multiplicity.
for instance, that equation, the answer is x is equal to 3, multiplicity 2, because the 3 could do it twice. Is that right,
Mm-hmm.
Anastasia?
Yeah.
So for this, the multiplicity is of 1.
1 for everything, correct?
Yeah. Yeah. Okay.
That works for you, Joseph?
I know, I'm just a little bit slow. Why?
You are all
Okay.
good, man.
Like I just found out the. What
So,
number?
how was work today, Hunter?
It was fun. I fell off a 30-foot thing. That was cool.
Did that hurt?
No, I had a harness.
Oh.
We're installing all these new industrial shelves and stuff, and I got a little greedy with the hammer, and I hit the beam too hard, and it came flying out, and so did I.
Huh.
Yeah, that was
That's
interesting.
cute.
That was
Okay.
fun.
Now,
I peed a little. It was a little scary,
all right.
a little spooky.
I found the. All
What
right.
do you
So
got?
x values would be x equal to 2, x equal to 3, and then x equal to 4.
And just when you
So, what
write
are the
them,
intercepts?
yeah, make sure it's in the intercept form where it's like
So it'd be like
3, 0.
A pair of coordinates?
2, 0,
Yeah.
3, 0, and 4, 0.
Correct. And what is the multiplicity of those, Joseph?
And what?
What is the multiplicity of all those?
That all the y-intercepts are I don't know.
What?
I was going to say all the y-intercepts was 0, but that's not the multiplicity.
Correct. The multiplicity is the x value, right?
Right?
Mhm.
And so how many times did those repeat? Those answers?
How many times they repeat?
Yeah.
I like to say like 3 times.
Did they ever repeat? Is there more than one x equals 2?
More than 1 x equals 2?
Yeah.
No.
Okay, so then it's only in there once. So the multiplicity would be
Only once?
Uh-huh.
correct.
Yeah, so
that-
when you have x minus 2 in parentheses and it is raised to the second power, it is multiplicity of 2. And
Okay.
if you have x minus 2 and all of this thing raised to the third power, it is multiplicity of 3.
Okay.
You have just x minus 2 and then all of the other stuff. So multiplicity is just 1.
All right. That's like why after the synthetic division. Is how
After you factored it.
after
Uh-huh.
I do it.
Yeah.
Okay.
Do you have a y-intercept for the function, Joseph?
No. Y-intercepts for the functions?
Yeah.
No, I do not.
Do you know how to find the y-intercept for the function?
Is it?
The y-intercept's when x is equal to 0, right?
Yeah,
Okay.
and that's why you just substitute the x, or like x with the 2, 3, and 4 one, or what I got for the
No,
no.
not when x is equal to 0. So you substitute 0 for everywhere you see x.
Okay.
So it'd be like 0x cubed minus 9x squared plus 26 times 0.
And the
Yeah.
only thing would be the negative 24.
Okay, so what would be the y-intercept then, Joseph?
It'll be 0, negative 24, right?
Exactly.
Yeah.
Cool.
I think
Alright, the
Ben
next-
will be a very good tutor. You should apply for tutoring.
That's what I say. Ben.
Are you getting A for this class? Get A and become a tutor.
Ben, it's as easy as that.
I
Do
don't
it.
know about that one.
Fine.
I don't like teaching math. It's too hard. Okay, next we need to find domain and range for the function.
Isn't it just infinities? Sorry,
What do you mean by infinity, Hunter?
that should be proper. Negative infinity to infinity.
Yeah.
Is that the domain or the range?
Usually, that'll be.
Yes.
Wouldn't that be like domain?
Yeah. And range.
Yep. And the range.
Okay.
Because even though it's barely moving right and left, it's still moving right and left forever.
Okay.
Just ever so slightly.
Now, is that open parentheses or closed brackets?
I am going to punch you. I struggled with that for 1 week.
Shouldn't it just be open parentheses?
Yeah.
You got it, Joseph.
Because those brackets is only if there's a limit.
Yeah, I'm still working with that.
No, it's a closed bracket if it's included,
If it's included.
Uh-huh.
not if it's a limit.
Like if the negative 3, whatever was part of it.
Yeah, so if the graph actually touches the point, it's a closed bracket. But if it stops at that point and doesn't touch it, then it's a open parentheses.
Okay. Only if there's like a stop point.
Mm-hmm.
Well, but I think Joseph was right. He just said that when it's negative infinity, you can't really determine it. So that's why it's like open parentheses. And You just usually put open parentheses and it's infinity.
Okay. Maybe you're right, and I was just being stupid.
Don't say that word. You're not stupid. You're beautiful.
Oh, thanks, Hunter. I think you're beautiful too. Tinted.
I'm tinted.
Okay, the next thing is here for the polynomial functions are.
The end behavior.
Mm-hmm.
Okay, is that just basically the leading coefficient and the degree of the polynomial function? Isn't that basically it?
As I understand it, what you're trying to figure out when you're trying to find the ends is as x is approaching infinity, what is y doing?
Oh, okay.
Okay. So in instance of this one, when x is approaching infinity, y is doing what?
Isn't it just approaching infinity?
Yeah.
So the end behavior is an infinity stone.
Okay, Buzz Lightyear.
Okay, what is wrong with you?
And you can also determine the end behavior, like Hunter said, by just seeing if at the very, very front of the equation there is minus or there is plus. Like if there is a squared or to the fourth power x to the fourth power, then both of the like end behavior goes up and then up here, like a parabola, and here's something going on. And then if it's like x to the cube and then x to the fifth, usually goes like one up and the other is down, or one up and the other is down. And then if there is no minus sign at the very front, meaning that it goes like that and here. And then if there is
proportional.
If it's understandable.
Yeah, I got it. I understood that. That was a really good way of explaining it, actually.
Yeah, that makes sense.
Okay,
it's basically based upon the parent function a little bit.
Mm-hmm. Yeah.
Yeah.
Okie dokie. You got that, Joseph?
I think I do.
Does everybody just have the parent functions written down? Because I can never remember them. I just have them all written down, all the information on them.
So the easiest way I have the parent functions memorized, Hunter, is that x squared and x cubed are pretty much the basis of everything. So like x to the fourth is just a faster growing with an extra loop in it, right?
Oh, okay.
And then x third has x to the fifth has an extra cross over the origin. I don't know how to explain that.
I would like to say of how it's. This might sound a bit stupid, but
hey, don't say that.
Okay.
You're beautiful.
You know how the like the little waves up on graphs? Like, hopefully I'm saying this right. Like, you know how well it's spread out, like right in between. So it'd be like, and like something like. Tell me if you see this. Something like that. Now, go and draw us exactly the same, but it's going to be looking a little different. So,
yeah, so it's about the bumps. So if you can see that this one is y equals x, it's got 0 bumps, right? Because it's a straight line. So it's got 1 less bumps than the x equals x, right? And here's x squared, it's got 1 bump because it's x squared, it's got 1 less. And here's y equals x cubed, and it's got 1 bump, and then 2 bump. And then here's x to the fourth, and it's got 1 bump, 2 bump.
Oh, you sly dog. That I never thought about the bumps like that.
So it has one less bump than the exponent of x.
Okay. Hey, Ben, you should just be a teacher.
Yes.
No
Because
thanks.
that's something I've never learned that ever.
Yeah.
You just someone has like 2 weeks worth of class from the end of high school. Or, yeah, go with that.
Moving on before I start blushing.
You're cute.
Asymptotes. Does everyone know how to figure out what an asymptote is and how to find it?
An isotope?
No?
The vertical and all that jazz.
Mm-hmm.
Yeah.
Is that a no? No one knows how to figure that out?
No.
Okay. What about you, Hunter? You know how to figure it out?
No, well, maybe under a different name, but what is the asymptote?
That cannot be touched but is approached.
Oh, okay, yeah.
It cannot be, but it's still a parabola?
No, because a parabola doesn't have an asymptote.
Okay.
An asymptote would be a place where the value can't be defined.
Okay. That's
An I to answer the question, or if it had a 0 in the denominator, those points can't be defined, and so it would be an asymptote. So because the line can never actually touch that, but it keeps getting closer and closer and closer and closer and closer. The closer the number it is. So
it'd be like trying to touch the x-axis, or like not the x-axis.
For instance, if I have the equation y equals 1 over x, x could never equal 0, right?
Right.
And so you'd have a vertical asymptote at 0, right? Because that line could never get touched.
And so that's the vertical.
Yeah.
A horizontal asymptote on y equals 0, because you can never get a 0.
Yeah.
If there's an x in the denominator and a constant in the top.
Okay.
Now that means for the graph that we're working with right now, it would be, let me see. Would it be 0 again, or would there be something else?
There is no asymptotes, right? Because the domain and range is infinity.
Yeah. I was thinking
so all values are fair play.
Okay. So
does that make sense?
So basically, it's reflected upon the domain and range almost.
Yeah, either one can be indicative of the other.
Okay, that makes sense.
All right.
And I'll explain it better in the next preparation question, because that's where they come into play. Which that one was fun to graph. All right. So we're ready to go on to the second preparation question, answering the same questions?
Yeah.
Okay. What do we have for a y-intercept?
Sure. Can't get this.
Y-intercept.
Let's see. Trying to.
Would it be 0, 0?
What do you have, Joseph?
Let me think this out,
Okay.
If it's like zeros. It's going to be on the top. I don't think that would be on the... That'd be 3. I'm going to say it might be a 0.
So in ordered pair, what's the y-intercept?
0, 0.
Yeah.
Because when x is equal to 0, y is also equal to 0 because the x by itself on the what's it called? The top of the function numerator.
Yeah.
Okay. So x-intercepts, that's the fun one.
Yeah. Especially when it comes to this problem.
Yep. So I want you to give me all the x-intercepts in a ordered pair.
Oh, yeah.
Okay.
And I need the multiplicity of said intercepts.
I'm done with that. Oh, wait a minute. No.
Do you have a mechanical keyboard, Hunter?
What?
Oh, it sounded like you were tapping on a mechanical keyboard.
Oh, no. That would be cool.
It would be cool.
I'm going to go get one now.
What are you going to use it for?
AutoCAD.
You don't need a mechanical keyboard for AutoCAD.
Inventor Pro. I don't know. Uh-oh.
Uh-oh.
He hates that.
Do you have your x-intercepts, Hunter?
Yeah, I do. 0,
Okay.
0.
And
3/2. I mean, 3/2, 0. Sorry.
what? So you have 0, 0, and 0, 3/2?
What's that? 3/2?
You have 0, 0, and 0, 3/2?
So 0, 0, and then 3/2 and 0. So 3/2, yeah.
How did you get that?
How did I get? So how did I get that? All I did was then so what I did is when I made it so it's equal to 0, then that's how I got 2x squared minus 3x equals 0. So 0. And then quadratic formula, which was
Okay.
plus 3.
You can't do the quadratic formula on this one, but that's okay.
You can't?
No, because you have a denominator, and so you can't just put it into ax plus b or ax squared plus bx squared plus c. equals 0, you can't put it into that equation, so you can't do quadratic.
There.
Okay, so let me ask you a couple questions, Hunter. If you have 0 over any denominator, what's it equal to?
0 over any denominator?
Besides 0. The denominator can't be 0. Right?
It won't work.
Correct. So, we know one x-intercept is 0, 0 because we know a y-intercept is 0, 0. Right? But you can also tell that because you can separate the two multiplied factors on the numerator and put those over to the denominator and equal those to 0. But we know that any value over the denominator that is 0 equals 0, right? So you can actually just get rid of the denominator.
Oh, I see that.
Right? So you just set x equal to 0 and x minus 2 squared to 0. So then now what do you get for x-intercepts?
So x minus.
Like when you're getting rid of these things, you're still remembering that x should not equal to like
1, -3, and 4. That's the only thing that it can't equal to because you'll just get a 0 denominator.
Okay. So those are your asymptotes. And can I ask you a question? So do you do group quiz week 3?
Yes, we did, but the person who's supposed to submit it dropped the class. So Hunter, I think, resubmitted it last night.
Yeah, I resubmitted it.
Hunter?
I submitted it with our group yesterday.
Okay, good.
Yeah, I put a little note there.
Yeah, we totally did it. She just dropped the class and didn't tell us she didn't submit it.
Yeah, I saw like about the group quiz something and I didn't understand, but now I figured this is quiz. Okay, good.
Yeah.
All right, so did you figure out the x-intercepts, Joseph?
X-intercepts? Oh. To be honest, no, I haven't.
No, would you?
Does it have to do with the bottom denominator? Because I only figure out what. No.
I mean, kind of, but not really. You need to figure out when y is equal to 0, right? So you set the equation equal to 0, and you solve for any value of x that will make that equation true. Right? And like I asked Hunter, if 0 over any denominator besides 0, what's that equal to?
Besides 0 or the 0.
0 divided by any denominator besides 0, what's it equal to?
You still have a 0 at that point.
Right? So then we know we just need to get it to be a 0 in the numerator section to find a correct equation, right?
Yeah. So if
what value would make the numerator 0?
What will make the numerator 0, huh?
Yep.
So it will just be anything besides a 0 is what I'm looking for.
Yeah, we've already established that 0 will get that. So correct me if I'm wrong. You're just basically trying to find the 2x squared minus 3x equals 0.
Wait, what was that? Say that again.
So you're just trying to find 2x squared minus 3x equals 0.
Where'd you get 3x?
Where did I get 3x? Did I write it down wrong?
Yeah, it's x times x minus 2 squared over
What are those numbers?
In the extension problems?
No, we're doing number 2 of the preparation problems.
Oh, that's why. I was on a freaking extension. I kept going back. I'm like, I'm pretty sure it's 2 over 2.
Let me. Yeah, I got 3 over 2 for that one. You got that one right.
Yeah. Then I did it like 4 times doing the quadratic formula, just making it equal to 0. That was really sad. All right, I see where we are now. I'm sorry.
You're on the wrong problem, Hunter. You got ahead of us.
No, I need to sleep more. I'm losing it.
You and me both.
Yeah,
You
buddy.
and me both.
Yeah. Let's nap together.
I'll be Big Spoon. Tomorrow night I'll be Little Spoon.
Woo.
You see where we're at now, Hunter?
Yeah.
Have you done this one yet?
Yeah, I've done it. I got 2, 0.
2, 0. So in an ordered pair.
For the x-intercept?
Yep.
Number 2 of the prep.
Yep.
All right. Make the numerator. Yeah. Squared and 0, 2, squared and 0, whatever. But yeah, if you use 2 for x as a numerator, then it's.
That's why I said one of the numbers in.
Yeah.
I used a 2.
So as an ordered pair, as if it's a coordinate, what are your answers, Hunter?
2, 0.
0, 2, you mean? Oh, 2, 0. You got it right. I'm confused.
You're scaring me.
Okay. Now, is that the only?
Is that like the only value?
So we set it 0, 0, now 2, 0.
Correct. Okay, what are the multiplicities of these intercepts?
2.
Which one? Both of them?
No, not the 0. You can't do that with the 0. Just the 2.
The 2, 0, 1.
2, 0. 2, 0, sorry.
Yep, the multiplicity of 0, 0 is 1, and the multiplicity of 2, 0 is 2.
Yeah.
Okay.
So now, by default, there's always going to be the multiplicity of 1. We can just establish that.
Yeah, because you're never going to get...
Exactly, okay.
That's not true. Because if you have like x to the 5th times x minus 2 squared.
Oh. I feel like we won't have to worry about that for a little while.
I'm sure we won't. Okay. All right, so what are the asymptotes for this one?
The end behavior?
Yeah, we can do the end behavior. That's fine too.
Oh, oopsie.
So as x is approaching infinity, what is y doing?
Yeah, also.
You don't know?
No, for the end behavior, would we just write it down as, how would we write that if it's also just infinity?
How do you write that? That's a good question.
TA.
You write it like this. Oh, I can't do that. I can't show. I'll show you on the other problem. So in the last problem, this is kind of how I wrote it. So as x is approaching infinity, y is approaching infinity.
Okay.
You see that?
Yeah. To explain the end behavior, if they're both just infinite, then you just put infinite, or
is
like.
Is that the case on this one? Wait, what was your question, Hunter?
No. So, like for example, like let's say it's a function like a cubic, where it's just infinite in both ways. Like what Ben wrote, you just do infinity, infinity for the end behavior. They're just both infinite.
You keep cutting out. Try saying it one more time.
So for the like, so when you're explaining that the x is infinity, and let's say y is infinity, for the end behavior, it's just you write infinity or infinity, infinity. How would you explain that? It's just.
I have no idea what you're saying, dude.
Okay.
So when x is infinity, meaning that so you have x-axis and then y-axis, right?
Uh-huh.
And then x is infinity, so it's like that way.
Uh-huh.
Y way. So meaning that from this this function goes up from this side, from in the first quadrant.
Yeah.
And then when the x is negative infinity, then y is also negative infinity. So it goes down in the third quadrant.
Uh-huh.
And you're asking how you should like put it on the paper, like
Yeah, like how would you write that as an answer, like when it's asking for end behavior and they're just infinite?
So how I would usually do that, I would just, for instance, if the end behavior is like parabola with the first one is up and the second is up, I would just put two arrows pointing up, and then if end behavior is like that, when in first quadrant is going down and in first going up, the first one down arrow and then the second one up arrow. But I'm not sure how it's like in America, how you write it, right?
Yeah, I'm sure that works. All
Okay.
right.
Like you just need to understand how to draw the.
That was just more of a technical term. Like, how would I put that on paper, rather than just saying infinity?
As x approaches infinity is how I would write it. Just as x approaches infinity.
Yeah.
Yeah, you could also write like that.
Well, can you also like apply like positive infinity and then a negative infinity?
Correct. That's what
That's what I was. Yeah. Okay. Deal.
Okay, so as x approaches infinity on this one, what does y do?
It also tries to go to infinity.
Nope.
No.
What are you doing now? Are you still in preparation?
What was that?
On preparation?
Yeah.
Okay.
We're slow.
And I was still in the
I
preparation.
hope you get paid by the hour.
We're gonna blow through these extension problems. Let me tell you.
So.
So as x approaches infinity on the second preparation problem, what does y do? Well, let's look at it this way. This is the expanded equation, right?
Yeah. I just have, there's no.
Yeah. If you
no
multiply it
real
out instead of putting in factor form.
Yeah. I know.
So as x approaches infinity on the top, the infinity is there and then is then squared, right? But if it's approaching infinity on the top, it's also approaching infinity on the bottom, right? So infinity cubed, right? So it approaches infinity faster on the denominator than it does on the numerator, right? That make sense?
So
would it be like, yeah.
That's the thing. I feel like there wouldn't be a definitive answer for that.
Well, no, because what's the largest number you can get if the denominator is a little bit bigger than the numerator.
Don't you always like get a decimal? If the
Yeah,
denominator.
but what value is it trying to reach if you keep increasing the numerator? I'm going to cover that because it gives you the answer.
Oh, I wasn't able to catch it since it was
So
below.
It approaches 1, right? Because it can never reach 1, but as infinity grows, it's just going to get closer and closer to 1.
Yeah.
The bottom, so it never will be 1.
So it'll be like acting.
Right?
I was going to say.
So that's the behavior?
Yeah, so as x is approaching infinity, what is it? What does y equal?
Approaching
Would be
what? I don't know.
1.
Yeah, it'd be approaching 1, but it could never be 1, right? Because there's no number large enough that 1 squared is equal to its.
That then technically just be the asymptote?
Yeah, that's what I was thinking.
Well, explain it better than me. Go for it.
So you're trying now to find the end behavior, right?
Yeah, we're trying to find the end behavior.
But you have asymptotes, and you have like different functions, how to say, and you're trying to draw them, and you want to find end behavior of each function you're drawing. I don't know if it makes sense. So what I would do, let me share my screen then. I think so. We have x. I didn't have mouse, so I'm not sure. X minus 2.
Amazing.
Okay, this is what is in denominator. So you would make, and this is something in denominator here. So you would make like a table, like 0, 0, and then here's multiplicity. So the first one, 0, is just 0 for the x, and multiplicity is 1. So meaning that the end behavior of this is just like that, right? You don't have to even like think about that. The next one is 2, and then it's 2. And then since multiplicity is 2, it's parabola, right?
Yeah. And
then here is plus sign, meaning that both of its like end behavior is going up and up. So you would have here on the graph asymptotes x equals to 0 here, and then x equals to 2, right? Let me see. Yep. And so this is an asymptote. 2, and so your vertex is, who knows what vertex is for this one? It will be 2 and 0, right? And 0. So it will be here. So it will be something like that. Like that. Something like that. Next, then we have, here was x minus 1. X minus 1. So you're trying to determine the end behavior for each of these small things.
So our answer will be.
Sorry, asymptotes are only on this on the bottom. So let's see, x minus 1. I don't know if you understand anything here. So it would be 1. The asymptote is 1. So here is 1. So we'll go here, right? And then the multiplicity is 1, meaning that it's just a straight line. And the same as with the other ones. I don't know if you can understand anything from this, but maybe.
I can understand that you like Minecraft.
Yeah.
Minecraft? Oh, I don't like it. It's my husband's.
Oh, sure. Put it on the husband. Put it on him. Go for it. Nice try. Okay, so
it was squared, and then
pretty much as it. Sorry, what was that? Keep going.
No, I'm just trying to figure out something was wrong. I didn't do this purpose, so. Yeah. So what did you say?
So pretty much as x approaching infinity on the second preparation question, y is approaching 1, right?
Yeah.
So would there be a definitive answer for the end behavior then?
Yeah, because it approaches 1. Trust me.
Shameless.
Maybe.
Yeah, I think you can determine end behavior because there are different like functions brought together. I don't know.
So it's I just put it. Approaching 1 /
Don't quit. Okay. Here's how I want to explain this. Okay. So back to covering that up.
Ben.
That, right?
Goodness.
The larger the number on the top, the larger the number on the bottom for x, right? But as both numbers get larger, the relative difference between the two gets smaller, right?
Yeah.
And as they get closer together, 1, right? But they can never actually be 1 because
1 would just
it's
make
a horizontal asymptote 1, and 2 because the bottom will always be bigger than the top.
Okay.
What does the answer key say?
What is the what?
You said the answer key? Why? No one said.
Did you have a question, Hunter? I didn't hear it.
No, I'm gonna check the dang key. Okay. Do you want to just move on to the asymptotes? Everybody?
You keep cutting out. I think my internet's going poopy.
Do you want to just go to the asymptotes?
Yes. Let's do that.
Okay. Well, I think we've established y well enough. It's 1.
Along with -3 and 4.
I think it's for X.
So y equals 1 is a horizontal asymptote, yeah?
Uh-huh.
Yep.
The vertical is 1, -3, and 4.
And everyone understands how to get those?
Yeah.
What's the domain range?
The domain I have. I wrote it down here somewhere. So -infinity to -3, open parentheses on both of them. And then from -3 to 1, open parentheses on both of them. And then from 1 to 4, open parentheses on both of them, to infinity.
And then 4 to infinity?
Open parentheses. Or 4 to infinity, open parentheses.
Yeah.
Yeah.
Bingo.
Cool?
Yeah.
Well.
What do we have for range?
How would you? Could you just put like all real numbers, or because it's not infinity, but it is technically numbers because all of them go towards something.
So if you substituted -1, right? So as you approach -3, the denominator is negative, right? And so is the numerator. Or no? So let me explain this. So as you approach -3, right? The numerator is positive because it's squared. And the denominator is negative, right? So as you get closer to -3, you approach -infinity for y, right? So the range is still -infinity to infinity. Does that make sense?
So you would put, even if it's multiple,
even if it has breaks in it and everything, it's still -infinity to infinity.
Okay, that clears that up then.
Okay.
Okay, I'll go take off because I don't think I'm a help. You're a good pen. So I'll go.
You're the new TA.
Thank you.
You have a good night, all right?
All right.
Okay.
Have a good night.
You too. Bye.
She's like, I've seen what I need to see.
Anyway, this is the graph.
These fools.
Yeah.
Hey,
It
Ben.
was really hard to come up with that, so I cheated.
Hey, Ben. I kept trying to defend the end behavior because on the key it says NA, and I was like, I don't know how to put this.
NA. That
Yeah.
was into nada.
Okay, let's move on to the quiz because I want to go to bed.
No, yeah, seriously. But hey, Ben.
Yeah.
While you were doing the end behavior, I kept trying to defend it for NA because that's what the key says, and I'm just like, ah.
Is that really what the key says?
That's what the key says. That's why finally I said, let's check the key.
That's stupid because I totally have an end behavior for that.
No, I know that. Like, I can see that that's how the end behavior would work. But I could see that the TA was just kind of sitting there.
Yeah, she was amazing. I liked her.
Yeah, she was cool.
Let's move on to the quiz.
Okay.
Here's the quiz. Done.
Do you have all the right answers?
I don't know. All right, let's do the quiz really quick.
Okay. This one you gotta do is like.
All right. How did you factor number 1?
How did I factor number 1?
Yeah.
No, you're supposed to have to.
I didn't factor it.
What?
How'd you solve for x?
No, you have to do that. Oh, I got
So basically, I just made it. I added the 45 to each side, so then it became the
a positive 45.
Yeah, so it's positive 45.
Yeah.
Mm-hmm.
And then using that, I then found basically using quadratic formula, the quadratic equation.
But how can you do quadratic formula when it's x to the fourth?
So what you do is you make it so, like for example, I just used like, let's say m or u or whatever you want to use. So then m squared equal, like, so m equals x squared and m squared equals x to the fourth. Does that make sense?
Oh my goodness, you're so smart. Mm-hmm.
And then once you solve it, then you just plug it back in.
So you did a. So you just used a quadratic formula?
Yeah. But
That was really clever. I would never have figured that out, Hunter.
I learned that last year, and my mind was blown because I never, ever even heard about that before.
I mean, you just substitute the A, B, and C in?
Yeah. But obviously that only will really work if it's like
later.
to the power of 2 and power of 4, power of 6. If it's able to be halved or divided.
14.
So I've got 7 plus or minus 2.
Let me take a look.
Oh, u is equal to that. Okay. So then u is equal to x squared, yeah?
Uh-huh. So what I got was
Negative 7 plus or minus 2. So x is equal to 3i plus or minus 3i and plus or minus I squared root of 5.
yes.
Really?
3i.
Holy cow! That blew my mind, Hunter.
You're welcome.
Wait. Hold on a minute.
Holy crap, that's so awesome of a trick.
A and C. Must have did something wrong with my. Did you do the positive 5 as you'll see? Right?
So for A, I got 1, B, I got 14, C, I got 45. Because it's a positive
Okay.
45. Yeah.
So let me times that 45 by that negative 4.
Could use a little salt too.
Okay.
Okay.
Has to be 180. Has to be positive 16.
Yeah, it is.
Then
I like it.
and then the square root of that will be 4. Okay, I don't know what, but I'm ending up with something different.
Yeah.
I don't know what, but I'm ending
Here you
up with
go.
something different.
Here you go.
Okay. Yeah. Yeah, those are the two numbers I got. Oh wait, that's where I was missing the square. Now I found it. I found my key.
Huh.
It's the square.
How did you solve the second one, Hunter?
How I solve the second one?
Yeah.
Kind of the same way.
Anyway,
So,
wait. I want to sing this before.
for example, like x squared plus 2x equals positive 5 minus 2x squared, yada, yada, yada. So I ended up with three answers, which were negative 5/2 and then negative 1 plus square root of 11 over 2, and then negative 1 minus square root of 11 over 2.
Okay. Let me get that real quick.
Okay. Because for
Sorry.
the,
I thought we would do the group quiz together, but
what's that?
I thought we were gonna do the group quiz together, but you were smart in doing it ahead of time.
Yeah.
I did not want to be here for 2 hours, so I just decided to kind of zone out and do it because I need to do a lot of other homework and I need to go get some stuff done for groceries.
Smart decision.
Yeah. Yeah.
I'm reading this right.
Oh, because it's a square root, it's not plus or minus in the quadratic formula. It's just plus, huh?
Uh-huh.
That's why it's only negative 5/2. Okay.
And I can see where you can get your three answers from. Two.
Yeah, I don't know how you got the second and third answer.
No, yeah, that's why I was just like, I got three answers. Here you go.
You should send me a picture of that one, how you solved that one.
I'll have to rewrite it because this is not legible.
Oh.
Yeah. Basically to find the negative 5/2,
No, I got the -5/2. That one I figured out.
You're talking about how I got the other one?
Yeah.
Because I decided to be a goober and plug that sucker in. It doesn't work.
I think I might. Well,
Wait. So
I think
when you're solving square roots, you just set one side to positive, and then the other time you solve it to negative, right?
Yeah, so -1 plus square root of 11 and then -1 minus square root of 11 over 2.
Wait, did you like put them all on one side? Can you move them all onto one side?
yeah, you can.
Wait, so this is what I got, Hunter. The first one I figured out, right? The second one, isn't that the equation for the second half?
I can't see it. X squared plus 2x equals.
But how do you get a quadratic with that? Because then
Wait.
the x squared is just cancel.
So what I did, this is where I think you're not really supposed to be doing this. When I added it, I basically took that where it was a +5 minus x squared, and then did the -5. So I ended up with 2x squared plus 2x minus 5 equals 0.
Oh, I see what you did.
Yeah, but I don't know if that's allowed.
Well, I'm just going to tell you, I know your answers are right.
Two x.
Let me see if Google will help me. I'm just kidding. I can't Google this.
Actually,
are we allowed to use our textbook during the quiz? Yeah, we're allowed to use our textbook. Let me find the textbook.
I actually found my notes to this problem.
Really?
Yeah, because I saw like a problem similar to this.
Are we allowed to use like on the internet?
No, we're allowed to use our textbook.
Yeah, well, no, I'm talking to Joseph. Like, you found notes of this on the internet?
No, his notes.
Oh,
no,
he found his notes.
This was on a homework assignment.
Of
a problem that was similar to this. Let me see.
But does that make sense? The 2x squared plus 2x minus 5, and then you use the quadratic?
No, I have no idea. I legit have no idea how to do this one.
Let me see if I can. Well, let me take a look at it a little bit.
Let me see if I can write this down on a better sheet of paper.
Oh, you set both sides to negative.
Yes. So both sides positive, both sides negative.
Really?
Yeah.
Does that make any sense now?
Yes.
And that's why I didn't know if it was allowed, because I was like, can I just make these parentheses instead of the bars? I don't like these lines. I just want parentheses.
Nope, that didn't work for me. Oh, yes, it does. I like how the teacher or the TA got tired of how long this took.
I can't hear you. What?
I like how the TA got tired of how long this took.
I can't hear you.
I like how the
How the
TA got
TA
tired of how long this took.
Yeah. We're running on an hour and a half. She's probably like, geez, it should only take like 25 minutes. I'm sorry, TA.
Okay.
Cool. I got it. I got him solved. I got that one solved.
Woo!
Okay. Now on to number 2.
All righty.
All right.
For number 2, all I did again was just factor it out. You just sit there and factor.
Did you use synthetic?
You can.
How did you factor it out?
I factored it out, and I eventually ended up with. Yeah, I'm gonna write this down. So it's more specific.
How do you factor this out without synthetic division, dude? I want to know how you do that.
I just factor out X.
Factor out X, huh?
Yeah.
Yeah, you can factor out an X. That's a good point.
And then it's a long and arduous process. But then, yeah, I'd probably just go with synthetic division. My factoring out took a long time.
You factor the X out. Then you have like 0 to be as one of your answers.
Uh-huh. So, pro tip, don't factor it out.
What was one of your factors, though?
What do you mean?
So
Like,
one of your X minus what was it?
X minus 2?
You have X minus 2 in there?
Yeah. This is like one of my last steps that I got the.
Okay.
Does that make sense?
Yep, I was just using that to figure out which one was the right one for synthetic division.
Oh, you dog.
I know I can do synthetic division. I just didn't want to sit there and have to do it the whole time.
Or try and find the right number to use it.
Oh, gosh.
Yeah.
So I'm learning. Oh, hello.
One, two, three, four.
I declare a thumb war.
5, 6, 7, 8.
Like, let's end this. Isn't that great? Hey, that's a lot better.
I know. If I hold the flashlight to my face, yeah, you can definitely see me then. But I don't want to sit there and hold a flashlight to my face forever. I guess I could. If I put it like this, it's not very. You still can't see me. Joseph, can you see me very well? I have the flashlight like.
I say it was a lot better with when you had that flashlight up to your face.
Oh gosh, I don't want. Oh, that just looks silly.
Like that.
That just looks silly. Oh, thank you. It's funny, like it detects light, and that's it. There's nothing else. It's just light.
So for your answer, do you have 0, 2, and Is that it? 0 and 2?
I thought there would be a lot more.
Oh. No. There's I and
Negative I, 1 minus I.
there's 2I and negative I.
Ah.
Okay, on to number 3.
Okay.
I'm interested in one of the slower groups or one of the faster groups.
I wonder what she's going to report to the teacher.
That was slow.
Exactly like that. They're slow. But do we fail?
The cost for making X number of plates food for Gion is $200, 5.5x plus that is equal to that. Okay, I can figure this out.
Yeah.
Well, he does say if we all slow, just you know the story of the tortoise and the hare.
Exactly. But did we lose? Did we fail the class? No. C's get degrees.
Oh. What's his name?
So I couldn't figure out the second part to this problem.
If the food sells for
Or whatever dollars per thing.
plate, then how many plates must that Dan must make and sell to make profit?
Yeah, that part.
What's the square root of 5,064?
You're asking me.
I got it.
Oh, that's what I have a calculator for.
Okay, so square root of
5,064?
I don't know. I gotta find my square root sign here. There we go.
What's your answer for number 3?
I got x equals 23, but I didn't get the second part because I'm having trouble with it.
Oh, because I'm an idiot. I did this whole problem wrong.
Well, you got a lot of decimals if it's 5. Oh, wait.
I did the whole problem wrong.
Okay.
Sorry, Hunter.
You're good. You usually.
Can you show your work on this one, Hunter? You there?
What's that?
Can you show your work on this one?
To find x equals 23?
Yeah.
Si, senor.
You can?
Wait, can I use my calculator?
You can use your calculator to solve it, but we have to take a picture of this and turn it in, right?
Ah,
Yeah.
shit. Okay.
Can you
The
show
way
your
that
work on it well enough for that?
Yeah.
Or should I just like copy it?
You want to just copy it, and I'll see if I can just whip it up. Do you use your calculator?
Do I use my calculator?
Yeah, did you?
I'm using it currently.
Oh. I'm whipping it up as fast as I can. I'm kind of BSing it.
Well, that's why this lead's not working, because I'm out.
Is your what?
Ah, there we go. I was out of lead. What's 91.5 times 91.5? Did you have to do any rounding on this one?
No. Usually just like 0.25, 0.5, 0.25.
What? I got 3,539.25 in the that doesn't factor. Correctly.
Okay. Maybe this. Yeah. This might help.
Huh, that's what I did wrong. For some reason I thought squared equaled 167. Here's 3.5.
Oh. The glory of the light.
6,972.
Beware the light.
I like how my fingers are still black. Like the computer just will completely get rid of me, but paper and anything else, yeah, that's fine. The crap computer is wrong.
You can put it down now.
Okay.
All right.
So the square root of 1400. What's the square root of 1400?
Square. 1 moment.
These are rhetorical questions, by the way.
1400 square root.
Rhetorical answer.
1400 square root.
Yeah.
Got 37 point.
Let me see the paper one more time, Hunter. Wait, how did you go from the number 1 to the number 2?
Oh, so number 1. So basically, right here, what I did is, so when you square each side, number 1 is the outcome of when I.
Oh yeah. Okay.
And then I just combine 1 and 2 for that.
And the number 2.
Okay, but how did you get from the last step to the second to last step? Quadratic formula?
Yeah. So, okay. I realized I skipped quite a portion, didn't I?
Yeah, we got to show our work so that we can get graded on our work.
Shiznit. So yeah, you do the quadratic formula, and so when it's the positive square root, all that crap, it's the 343, which doesn't work if you plug it in. But then if you do the
Okay,
negative,
but I'm getting the square root of 1400, which does not come out pretty.
Yeah.
how are you getting the square root of 1400?
Because it's 88,372.25.
Wait, what?
Oh, because I have that part. No, I have that part right. So your simplified equation is 0.25x squared minus 91.5x minus 600 or 6,972, right? 0.25.
No. It is not.
No.
So what I did is I multiplied each side by 100 to get rid of the decimal. So I don't have to play with that anymore. And then when I simplified it, I got 25x squared minus 9150x plus 197,225 equals 0. And I plugged that into the quadratic formula.
Wait, you got 25x squared minus. Can you hear me?
What's that?
You got 25x squared minus.
Basically, just move the decimal over 2 times.
Yeah, but your second coefficient, the b, is at 91.5 or 9105?
The b is 9150.
Okay, and then for c, you got 697225.
No, I got the
Oh, I see what I'm doing wrong.
197225.
197225. That's my problem.
When you make it 0 to equal 0, then you have to, yeah. Sí, señor.
Oops.
What's the square root of 6400?
Wait, what?
Shoot me, Hunter. Shoot me. So one more time, you've got 25 x squared minus 9150 minus 1972.25 is equal to 0.
Plus 1972.25.
Plus 19.2. Okay. Did I do 91.5 times 91.5 wrong? 8372.25 minus 1972.25 equal to 6,400. Square root of 6400. Oh, 80. There we go. I just can't use my calculator.
You're good.
80. X is equal to 2 times 11.5.
Hey, when does the semester end, by the way?
Sometime in August. Okay, my other question is, so I have 2 times 91.5 plus or minus 80. Why isn't it also 170 something?
Yeah, what'd you get?
I got 23, but I feel like there should be a second answer, and why isn't the second answer part of the question? Anyway, I don't really care.
It's just a doozy.
Okay. If the food sells for
$4.49 per plate, then what's the minimum number of plates that Gone must make and sell to make a profit?
what is the minimum number of plates to make a profit? Okay, let me think about this. Okay, so you set the equation, instead of setting the equation to 83.5, you set it to that. Wouldn't you think? Wait. let me think about this. So we know the cost is it costs him $83.50 to make 23 plates. $83.50 per plate if he makes 23. Okay, yeah, I'm doing this right. Does that make sense, Hunter?
What's that?
Instead of it being 83, you just put it 4.49. That's what the question's asking.
Okay, yeah.
Um, Are you just staring at the computer, Hunter?
Me?
Are you just staring at the computer?
I'm doing a quiz that's due in an hour.
Oh, okay.
Sorry, I just have 2 other things that are due.
You're good. You're good. I got 168 plates. Sound good?
Yeah. What did you?
Like, yeah.
Ah.
You still need that?
I can say it looks good.
Looks good.
Yeah.
Look good to you too, Hunter?
See.
Okay, I'm gonna take a picture and send it to you. Let's call this good.
All right.
Okay.
Yeah,
See.
send me the link and the picture, and I'll send everything in.
Okay. Sorry it took so long, Hunter.
No, you're good. Sorry, I just kind
All
of zoned out last little bit. I'm just trying to finish 2 quizzes.
No, you got stuff to do and you're busy. I get it. Tuesday, 8 o'clock. We'll plan
Yep.
on that and we'll just figure it out from there. Okay.
Yes, sir.
Okay.
All
All right.
right.
See you guys.
All right.